Hey, what's up, guys? This is Cheng here again. So today, daily challenge problem, right? Number 583, delete operation for two strings. Okay, so you're given like two strings, right? Word one, word two, and you need to return the minimum number of steps required to make word one and word two the same, right? And how can we make them the same, right? So the only option we can do here is by delete some characters. And obviously we can always make them to be the same, if we just remove everything, right? Because empty string equals to the empty string. But we want to get the minimum number, right, of that. So for example, we have this kind of SEA and EAT, right? So for these two words here, the answer is 2 because, we need to remove S from the first word and we need to remove T from the second word. And in example 2 here, we have ETCO, so which means that we need to remove LE and then DE. That's the two parts we need to remove. Okay. And yeah, and we have some like constraints here. The constraint actually is not that big, but still, right? So, you know, if we only want to do this in the same way that in the trying to delete the letters, that will be very hard because we because we don't know which letter we want to delete, or if we want to delete, let's say for example, if the S and the E they're different, so which one we want to delete, we don't know, right? I mean, that's why if we look at this problem a little bit deeper, actually, so the reason we want to the reason the minimum, right? So in order for us to return the minimum number of steps we need to remove from both strings. Actually, it's equivalent to finding the longest common string among those two words, right? So for example, in this one, the common string here, it's like if we have like this one, SEA AB C, right? And for the other one, let's say we have EA AB CD. Okay. As you guys can see, so this one, the longest common string is this one. That's why, as if we can find the longest common string between those two words, we can simply, we'll find the m plus n, right, minus 2 times that longest common string, right? So where m and n is the length of the word. So now, in order to find the longest common string, that's a very classic DP problem, right? Where there's actually this one is a like very typical two strings DP problem. If we ever want to solve a two string DP problem, we always want to define like a two-dimensional DP, right? Where DP I and J, okay. So DP I and J means that for DP we always want to define like state, right? So for this kind of two word two string problem, we always need two state. Where the first one is basically this one means that for the first I's letters from word one and the first J's letter from the word two, what are the the most common string, the longest common string, right? Because this is it's kind of like for the DP problem, because as long as we can get this one, because there's like state transition function here, right? Basically this one equals to what, equals to the it depending on the current one. Basically, if the I's letter in the word one and the J's letter in word two, if they're the same or not, right? Basically, if the word one, right, word one I equals to word 2j. Okay, if that's the case, right? So what does it mean? It means that at least it's going to be a 1 plus, right? 1 plus dp I minus 1 and j minus 1. Okay, right? Else what? Else going to be a max of dp I j minus 1 or dp I minus 1j, right? So what does this mean? It means that, let's say we have like two strings here, right? So if we have like this two string here, it doesn't really matter the length, right? Let's say we have this kind of right, and this so this is I, this is j. Okay, basically, we're at this kind of state, right? We're comparing this I and j. If these two are the same, then it means that okay, at least we have one common string here, right? That's why we do 1 plus here, and then the remainings are what? The remainings are the sub problems. In this case, the sub problem is a previous one. Basically, it's the I minus 1 string and from the word 1 and the j minus 1 string from word 2, right? Because if we know, right? Because okay, so the definition for this one actually is okay, so besides the first i's character and the first j's character, we also have like a second condition here, which that the string has to be ending with this character here. That's the one part of the definition, right? Which means that so again back to here, right? So if this one are the same, and then so the sub problems will be this one. So what's this one? That's the string ending with I minus 1 and the string with the word 2 ending with j minus 1, which is this part, right? That's the so that's why we can just solve this problem by using a dp, by breaking down this dpij into a sub problem. Basically, we're reducing the size of the problem, right? And else, right? So this is the case where this I and j are the same. If they're different, then what do we do, right? If they're different, we have two options basically. So we either compare this part with this one, right? Or we compare I minus 1 with j. I minus 1 is this part, j is this part, right? Because we know, since these two are different, there's no way we can find the like common string here. That's why we have to try to compare the others, right? We have to either skip this one or we skip this one. That's why we have two options here. Yeah, and we just keep going this one until basically we keep splitting this big problem into a smaller problem. As you guys can see, we always go back to I minus 1, j minus 1. In the end, so the base case, right? The base case is 0, right? So which means if there's no string a letter at all, the length will be 0, right? So that's basically the DP idea here. Okay, I'm talking about this one for for you guys who are not that familiar with the DP, at least for this kind of two strings DP concept. Yeah, for those who already know this concept, this one should be pretty straightforward because there's actually it's kind of like a pattern, a fixed pattern for the string DP two string DP problems, right? Cool. So and then I think we can start coding it. So first we need a two length, right? So like I said, we need a m word 1, and then we have n equals the word 2, right? And then we need to define the size of the DP. since we'll get the I minus 1 and j minus 1 in our dp state transitions function, that's why we when we define the dp array here, we do a n plus 1 and n plus 1 so that when we don't have to worry about the I minus 1, j minus 1 because the I and j will be starting from 1 instead of 0. That's how we handle this one. Okay, so and then we can just start looping through those two words, right? The two strings. So like I said, we'll be starting from 1 to n plus 1, right? And then the inner loop will be j in the range of 1 to n plus 1. Okay. And then we compare the string for I and j. So since the I starts from 1, since I is 1 based, right? And the word is 0 based, that's why we have to use the word 1 dot I minus 1, right? Word 2 dot j minus 1. Okay, if they are the same, then we know, okay, we can dp, basically dp ij will equals to 1 plus, right, the dp of I minus 1, j minus 1, right? Else dp ij equals to max, right, of dp I minus 1, j, and then dp I j minus 1. Okay. So after this nested for loop here, the dp m and n, or the dp minus 1, will store the longest common string for those two words. Okay, and in the end, we simply return m plus n minus 2 times, right, the dp minus 1 and the minus 1. Or you can use m and n, they're the same, right? Yeah, because we want to subtract twice as this one, right? That's gonna be the letters, right? The minimum letters we will need to remove. Okay, cool. So run the code, accept it, right? Yeah. So that's it, right? Yeah, I mean, okay, again, so this base case, right? So I mean, as you guys can see here, we're starting from 1 1 here, right? So for dp 0 and 0, it means what? It means so for dp 0 and j, it means that basically the first string is empty, and the second one is not. Basically, between the empty string and the non-empty string, the longest common string will always be 0. Same thing for the I and 0 ones. Right, so this one is similar to the other one. Basically, between the empty and non-empty string, the longest the common string is always 0. That's why I don't have to set this kind of like edge case separately, because when we initialize the DP, we have already set everything to be 0. Cool. That's it. Oh, so the time and space complexity, right? Pretty straightforward, right? So for the time and space complexity, they're both m times n. And that's it. Cool. I'll just stop here then. All right. Thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.